So now I'm going to do a parabola, and I'm going to go through the different things that we might need to know about a parabola. So first of all, I'm going to show the methods of construction. Okay. So I'm going to draw a rectangle that's 100 mil by, say, 120 mil. Okay. Now this is to draw a parabola inside a rectangle. So to draw the parabola inside the rectangle, as shown, we have to divide it up into equal parts on each side. So when we're doing this here, the parabola, one point will be the vertex. So we're going to call this point here the center point at the top, or if we orientated that 90 degrees to the left hand side, would be the vertex. Okay, so what we have to do then is divide these up into equal parts. So I've used 50 as our gauge here. So I'm going to obviously divide it up into 5 equal parts. Now, there are 5 equal parts. So what we're going to do then is divide up the side over here to be the same. So now, obviously that's going to be the same on the far side. Now, so parallel to the line, the center line from the vertex, we'll draw these points up. So I've divided into 5 equal parts each side, as you can see. Where V, or the vertex, is the top of the parabola. Now, so we're going to label these here 1, 2, 3, and 4. 1, 2, 3, and 4. And same over here, 4, 3, 2, 1, 1, 2, 3, and 4. I hope you can all see that. So what we do is we join 1 back to V. I'm going to do that in a red pen. Where it crosses the one line, that is a point in our curve. Oh, and this corner would also be a point in the curve, sorry. Then we'll bring the point 2 back to V. And where it crosses 2, that's another point in the curve. 3 back to V. Where it crosses, that'll be another point in the curve. And 4 back to V. And that will give us another point. And we would do the exact same on the other side. And that will give us our curve. So and that will give us our parabola via the rectangle method. So just to illustrate again, I'm going to bring 4 back over to V, where it crosses my 4 line. That is my point. Bring 3 back up to V, the vertex, where it crosses, that's my point. I'm going to bring 2 back up. where it crosses 2 is going to be my point, and finally we're going to bring 1 back up, and where it hits it, that is my other point. So a fairly simple method. It will tell you which side is the vertex, or the vertex is the top of the parabola. Okay, so that is a very simple version, and that is the rectangle method for drawing a parabola. You draw lines parallel through the center line from the side opposite V, and then on the side, the right and left hand side away from V, you've divided up into the same number of equal parts, and you join them all back to the point V. Now if V had to be down here, we would have drawn them back this way. Okay, and if you turn that to the side, you would see that if V happens to be in the left, then it would be the top and bottom points that we brought back to V. Okay, I hope that makes sense. Now I'm going to move across here, and we're going to draw an ellipse or a parabola using the eccentricity method. Now, so we're going to call that, it doesn't really matter what we call that, to be honest. But what we do is say we're going to have a directrix, say we're going to have a vertex, and because it's a parabola, the distance between the vertex and the vertex and the focus, so basically if I drew a circle here, this being the vertex, this would be your directrix, and this would be your foci point, or focal point, whichever you want to call it. Now, the eccentricity for a parabola is always going to be 45 degrees because it's 1:1. Okay? Now, from here, right, this is called our line of eccentricity. So I'm going to call that our line of eccentricity. Okay, and this here is also the line of eccentricity down here. Now, the distance to any point in the curve will be the same distance from the focus as it will the directrix. So if a point's over here, the distance from the focus to the directrix will be the same. So a line 90 degrees to the directrix and down to the focus, okay, will give you the same distance. So it doesn't matter what distance I use. So what we're going to do is I'm going to show you what I mean. So I'm going to draw a line through the focus till it hits it. Now, these will always be points in the curve. That is definitely a point in the curve. That is definitely a point in the curve. That is definitely a point in the curve. Now, the distance from the directrix to the vertex is the same as the distance from the point in the curve to the focus. Can you see? So there to there is equal to there to there. We know the V is always going to be a point, the vertex, the top of the parabola. Okay? And the reason we know that these 2 points are definitely going to be points on the curve is because that's 45 degrees. So if I draw a line across, the distance from the directrix to this point will be the same as the distance from the focus to this point. So there are definitely 2 points on the curve. So now we've got 3 points on the curve. Now, for any other point, it doesn't matter what distance it is. Okay? So if we draw the line here, for example, now we know, okay, that their line's parallel, and we know that that's at 45 degrees. So we would be correct in saying that if I kept drawing these here, lines out like this, and they kept hitting our line of eccentricity, then this distance here would be the same as this distance here. And this distance here would be the same as this distance here. However, that distance there can't be correct because it's further away from the focus. So what we do is we take the height of each point to our line of eccentricity. Okay, and we swing it from the focus. And we now know that that is a point on the curve. Why? Because that distance has remained constant and that distance has remained the same too. So we now have a line from the focus to the point in the curve. So this line here, let's see, is 63 mil. And this line here, or 68 mil, sorry. And this line here is also 68 mil. So what you'll see is, if you continue to draw them lines out, so I'm going to do the same with 2 actually. So the distance from here to here. Now they can be any distances. The distance between them steps doesn't really matter. Okay? The distance between them steps doesn't really matter. Okay, so if I could continue on out and could do another one out here, doesn't matter where I draw the line, because I know that if I drew that square there, that this side would be the same as this. As you can see, these are all squares. So all I have to do is take the height of this line, go back to the focus, and swing an arc, and that will give me another point in the curve. So now the curve will start to take shape. As you can see. Okay. So it doesn't matter. I could continue that on out even further. And as you'll see, as we continue on out, it still remains the same practice. So what we're going to do is we're creating squares. So as you can see, because it's a 45-degree angle, that's going to create another square of equal measurements. I hope you agree with that, because that's correct. And what we will do is take the length of the line, go to the focus, swing an arc, and that would give us another point on the curve. Okay. Now, if you're given the directrix and the focus, and you weren't given the vertex, what you would do is you draw a line perpendicular to the directrix through the focus. Again, you know that the eccentricity is always going to be a 45-degree line. So what we would do is, and this goes the same for all of them, when you're given the eccentricity, the focus and the directrix, if you draw a line back at 45 degrees to hit your line of eccentricity and drop it down, you will always get your vertex. Okay, now eccentricity method. Now, the eccentricity method and the compass method would be very similar. So if you had the focus and you had the vertex and the directrix, you could just measure from the directrix out to any point and swing it from the compass till it hits the same point. It's the same system that actually applies, you just don't need the line of eccentricity. But it's the exact same procedure. So if I decided to do the compass method and I didn't have the line of eccentricity, I could draw any line up here. So I'm going to draw a random line. Okay, I can just get the distance from my directrix to that point. Okay, and go to my focus and draw the point. So in this case here, I'm just going to measure from the directrix to the vertical line, which is at 90 degrees to your axis. That's your axis. And so once we've done that there, All we have to do is get your distance to there, get your focus, and swing out an arc. The eccentricity and for a parabola, the eccentricity method and the compass method are very, very similar, except for with the eccentricity method, you may draw the line of eccentricity. If you decide not to draw the line of eccentricity, you measure from the directrix to the line perpendicular, and from that distance you may swing an arc from F. Okay, so this here is basically you're actually using squares, and this one here you're just measuring the distance from D to a point. Where you've drawn that line, you draw a line straight up, and you get that measurement and you swing the distance from F. Very simple. Thank you. Bye.